You have seen some of the data types supported by MySQL. It's really important for you to understand these data types and when to use which, because in the next section, we're going to talk about designing databases, and that's where you're going to use these data types. So in this section, we're going to explore all these data types. In MySQL, we have several categories of data types. We have string types, numeric types, date and time types, blob types for storing binary data, and spatial types for storing geometric or geographical values. Over the next few lectures, we're going to explore various data types in each category. So let's get started. In the string category, we have a bunch of data types. The most common ones are char and varchar. As I told you before, we use chars for storing fixed length strings like the abbreviation of states, and varchar for storing variable length strings like usernames, passwords, emails, addresses, and so on. Now, even though these are string types, we can also use them to store numeric values like zip codes and phone numbers, because we don't use these values in mathematical operations. Also, sometimes these values may contain a hyphen or parenthesis to group a few digits, and that's another reason that we should store these values as a string of characters. I personally like to use a standard length for most of my varchar columns. For example, I use 50 for short strings like usernames and passwords, and 255 for longer strings like addresses. This consistency simplifies the maintenance of your databases. You don't have to constantly check the lengths of each column. Now, the maximum length for varchar is just over 65,000. So if you store something that is longer, it will get truncated. To prevent that, you can use medium text, which allows you to store up to roughly 16 million characters. And this is good for storing JSON objects, CSV strings, and short to medium length books. We also have long text, which can store up to 4 gigabytes of textual data. And this is good for storing textbooks or years of log files. These are the main string data types that you'll be using most of the time. We also have tiny text, which can store up to 255 characters, and text, which can store up to 65,000 characters, just like varchar. But for this range of characters, it's better to use the varchar type because it can be indexed. We'll talk about indexes later in the course, but basically, we use indexes to speed up our queries. Also, all these types support international characters. English letters use 1 byte, European and Middle Eastern languages use 2 bytes, and Asian languages like Chinese and Japanese use 3 bytes. So if the type of a column is char of 10, MySQL will reserve 30 bytes for the values in that column. Next, we'll look at integer types. We use integers to store whole numbers that don't have a decimal point, like 1, 2, 3, 4. In MySQL, we have 5 integer types, and these are different in terms of the number of bytes they use and the range of values they can store. Obviously, the more bytes we have, the larger the numbers we can store. So we have tinyInt, which takes only 1 byte, and with this, we can store the numbers minus 128 to 127. Now, if we mark a numeric column as unsigned, it can only store positive numbers. So with an unsigned tinyInt, we'll be able to store the numbers 0 to 255. This is particularly useful when storing positive values like people's age. If we mark this column as unsigned, we can prevent a negative value from being accidentally stored in our database. Next, we have small int, which takes 2 bytes and gives us a bigger range. We also have medium int, which takes 3 bytes, int or integer, which takes 4 bytes, and big int, which takes 8 bytes. Now, don't worry about memorizing any of these ranges. You can always Google MySQL integer types, and you will see this table that clearly shows the number of bytes for each type, as well as the range of values they can store. Now, if we try to store a value outside the range of a column's data type, MySQL throws an error saying the value is out of range, so our insert and update operations will fail. Also, apart from unsigned, numeric types have another attribute, and that is called zerofill. This is useful in situations where you want to zero pad the values so they always have the same number of digits. When defining a numeric column, we can specify the display size in parentheses. For example, with int of 4, our numbers will always have 4 digits, so the number 1 will be padded with 3 zeros. Note that this will only affect how MySQL displays these values, not how it stores them, okay? Now, as a best practice, try to use the smallest data type that suits your needs. With this, your database will be smaller in size, and your queries will execute faster. For example, if you want to store the age of people, you can use an unsigned tiny int. No one is going to age more than 255 years, at least not anytime soon. So 1 byte is sufficient to store people's age. You may think that saving a byte or two doesn't really matter these days because disk space is cheap. That is true, but trust me, if you're dealing with large amounts of data, your queries will perform better if you use every byte consciously, because these bytes of data will have to be transferred between the disk and the memory. So the less data you have in memory, the faster your queries are going to be. So keep things smaller and more compact. In MySQL, we have 3 types for storing numbers with a decimal point. We have the decimal type, and this is useful for storing fixed point numbers. These are the numbers that have a fixed number of digits after the decimal point, like monetary values. When using the decimal type, we need to supply 2 arguments, precision and scale. The precision specifies the maximum number of digits, and this can be between 1 and 65. The scale determines the number of digits after the decimal point. For example, with decimal of 9 and 2, we can store a number with a maximum of 9 digits. We have 2 digits after and 7 digits before the decimal point, okay? Also, this decimal type has a few synonyms. They are dec, numeric, and fixed. These are exactly the same. So just stick to decimal and keep things consistent. I mentioned these synonyms in case you see them in databases designed by others. We also have the double and float types, and these are used in scientific calculations. If you want to perform calculations with very large or very small numbers, you should use these types. Just remember, these types don't store the exact value, they use an approximation. That's the reason they allow us to store really large or really small numbers. Float takes 4 bytes, double takes 8 bytes, so obviously with double we can store larger numbers. So if you want to work with exact values like monetary values, you should use the decimal type. If you want to work with really large or small numbers in scientific calculations, and the precision is not important, you should use float or double. There are times that we need to store a yes or no kind of value. For example, is this blog post published or not? That's when we use Boolean values, which are true and false. In MySQL, we have a data type called bool or Boolean, and this data type is actually a synonym for tiny int. So with a Boolean column, we can write code like this. Now, this true keyword you see here is internally represented as a 1, and false is represented as a 0. So we could rewrite this code like this. In my opinion, true and false keywords are more descriptive, but I leave it up to you to choose the style that you like. What you need to understand is that true and false are synonyms for 1 and 0. There are times that we want to restrict the values for a column to a limited list of strings. For example, you might have a column called size, and in this column, we only want to allow the values small, medium, and large. This is where we use the enum type. Let me show you. Here in our SQL Store database, I'm going to open the products table in the design mode and add a new column here called size. Now let's set the type of this column to enum, and here we need to pass 3 string values. Small, comma, medium, comma, large. Let's close the parentheses and press tab. One more time. And then click on apply. So here are the changes. We're going to add a new column called size. And the type of this column is enum of these 3 values. Let's apply the changes. Now let's open the table and set the size of one of these products here. So the only values we can set here are small, medium, or large. If we use anything else, MySQL is going to give us an error. So here we can type small in lowercase or uppercase, it doesn't matter. Now let's apply the changes. Beautiful. I'm going to close this tab and reopen the products table. Now look at the size of the first product. It's small. So this is how enums work. Now, while this may look appealing to you, in my opinion, enums are generally bad and you should avoid them. The first reason is that changing the members of an enum can be expensive. For example, let's say tomorrow we decide to come back to our products table and add a new member here, or maybe rename one of these members. MySQL is going to rebuild this entire table, and this can be expensive if we have millions of records in this table. Also, with this approach, we can add additional attributes to each member. For example, what if we want to include the actual measurements for each size? We can do that. Also, if you want to get the list of all possible sizes and display them in a drop-down list in our application, you have to do a bit more work. It's not that easy. Plus, these enums are not reusable. So if you have another table and we want to reuse these values there, in that table, we need to redefine this enum with these members. And that duplication means if we decide to make a change in one of these members, we'll have to apply that change in multiple places. So these are some of the reasons that I believe enums are bad and you should avoid them. A better approach is to have a separate table called sizes. In this table, we can store all the sizes and any additional attributes they have, like their measurement. We can reuse this table in multiple places. And if we want to get all the sizes, we write a single select statement. That's really easy. We refer to this kind of table as a lookup table. In our SQL invoicing database, this payment methods table is also another lookup table. Quite often, we use these tables to feed our drop-down lists. So, back to enums. Just because MySQL supports them doesn't mean you should use them. I only explain them here so you're aware of them and know why they are bad. We also have another similar type called a set, but a set can store multiple values. So similar to enums, we specify the list of allowable values, and then we can store multiple values in a column. Again, this is really bad because it causes all sorts of issues. In the next section, when we talk about normalization, you will learn a better approach to deal with these scenarios. In MySQL, we have 4 data types for storing date and time values. We have date for storing a date without a time component, time for storing a time value, date time, timestamp, and year for storing a 4-digit year. We often use timestamps for keeping track of when a row was inserted or last updated. We can also use the date time for that. The difference is that timestamp is 4 bytes, and it can only store dates up to the year 2038. This is called the year 2038 problem. Date time uses 8 bytes, so if you want to store dates that go beyond the year 2038, you should use the date time type. We use blob types to store large amounts of binary data like images, videos, PDFs, Word files, pretty much any binary data. In MySQL, we have 4 blob types, and they differ based on the maximum amount of data they can store. We have tiny blob for storing binary data up to 255 bytes, blob for storing binary data up to 65 kilobytes, medium blob for storing binary data up to 16 megabytes, and long blob for storing binary data up to 4 gigabytes. Generally speaking, it's better to keep your files out of your databases because relational databases are designed for working with structured relational data, not binary data. If you store your files in a database, your database size is going to increase pretty quickly and that will slow down your backups. You will also experience performance problems because pulling images out of your database is always slower than reading them from the file system. Plus, you will have to write additional code to read or store images in a database. If you have valid reasons for storing your files in a database, first, take all this into account and make sure these reasons don't apply to your scenario. In MySQL, we can also store JSON documents. In case you're not familiar with JSON or JavaScript object notation, it's basically a lightweight format for storing and transferring data over the internet. It's used heavily in web and mobile applications, so most of the time, your mobile apps send your data to the backend using JSON. In JSON, we use curly braces to define an object. Inside these braces, we can have one or more key value pairs. Keys are always strings, so we need to surround them with quotes. Values can be anything. They can be strings, numbers, booleans, arrays, or other objects. So in our SQL Store database, let's open up the products table and add a new column here. We're going to call that properties to store additional properties about each product. For example, clothes can have a size and color, but things like a TV have other specs like weight, dimension, and so on. So it's not a good idea to add several columns in this table where only a subset of these columns apply to each product. This is where we can use JSON to easily store multiple key value pairs about each product. So we call this column properties and set its type to JSON. All right, now let's apply the changes. Beautiful. Now, in case you get an error at this point, you need to go to the MySQL Workbench menu on the top, go to Preferences. Here under Modeling, select MySQL. Make sure your target MySQL version is at least 8. So here I'm using 8.0.15. If you have an earlier version number here, you're going to get an error. All right, now we have this JSON column here. Let me show you how to use this. So in this query window, I'm going to update the products table and set the properties of our first product. So this equals, here we add single quotes, and in between these quotes, we define a JSON object. So earlier I told you that we use curly braces to define an object. In between the braces, we add one or more key value pairs. Our keys are always strings, so we surround them with double quotes. Let's say dimensions. Then we add a colon, and here we set the value. In this case, I'm going to pass an array, which is a list of values. Let's say 1, 2, and 3. Next, we add a comma to add another key value pair. Let's say weight, we set this to 10. And finally, let's say manufacturer. We can set this to a string like Sony, but let's make this example more interesting. I'm going to set this to an object. So here we're dealing with a nested JSON object. In this object, I'm going to add a property or a key called name, and the value for this key is going to be Sony. Now finally, let's apply our where clause where product ID equals 1. All right, let's execute this. Beautiful. Now I'm going to open another query window. Let's select everything from the products table. So here's the first product. Look at the properties column. This is our JSON object. Now we can query this object and extract individual key value pairs. I'm going to show you that in a second. But before we get there, let me show you another way to create a JSON object in SQL. So here we're using single quotes, and in between the quotes, we're using the standard JSON format, curly braces and key value pairs. But in MySQL, we have a few functions for creating JSON objects. So I'm going to delete this string here and instead call the JSON object function. In this function, we can pass multiple key value pairs. For example, we can set weight to 10 and dimensions. Let me zoom out a little bit. All right. We can set the dimensions to an array. For that, we need to call the JSON array function. Let me break this up into multiple lines. That's easier to read. So we set the weight to 10, dimensions to an array. In this array, we pass multiple values. Let's say 1, 2, and 3. We need one more key value pair. That was our manufacturer. We set this to a JSON object. So JSON object. In this object, we're going to have a key called name. And the value for this key is going to be Sony. And then we need one more parenthesis to close the call to the JSON object function. So what we have here is exactly identical to what we wrote earlier. But here we're using the internal functions in MySQL. Let's execute this one more time. Beautiful. Now back to our other query window. We can extract individual key value pairs from this JSON object. And this is the benefit of defining this column as a JSON column as opposed to a varchar, because with strings, it's very difficult to extract individual key value pairs in a JSON object. So here I'm going to select the product ID. And let's say from the properties column, we only want to extract the weight. So we call JSON_extract. The first argument to this function is a JSON object. In this case, what we have in the properties column. The second argument is a path. So here we add a string. In this string, we add a $, and this represents the current JSON document. Then we use a period to access individual properties or keys. in this case, weight. Now let's apply a where clause as well, product ID equals 1. So, as you can see, we could successfully extract the weight for this product. We could also give it an alias like weight. That is better. But there is a shorter way to write this code. Instead of calling the JSON extract function, we can use a special operator to access individual properties in a JSON object. Let me show you. So, we start with our properties column. Then we add this operator, hyphen greater than. This is called the column path operator. And then we add our path. So $, that is the current document, dot weight. This returns exactly the same result as before. Now, what if you're dealing with a key whose value is an array, like the dimensions? We get that array here, but we can also access individual items in this array. So here we add square brackets, and inside these brackets, we specify the index of the item we want to retrieve. To get the first item, in this case 1, we pass 0. Now, we get the first item in this array. What about working with nested objects, like the manufacturer property? So we type manufacturer. As you know, this returns a JSON object. Once again, we can use the period operator to access individual properties in this object. So manufacturer.name returns Sony. But because Sony is a string, we see double quotes here. Sometimes this is not desirable. For example, we might have this expression in a where clause, and let's say we only want to get products whose manufacturer is Sony. We don't want to get rid of these quotes. That is where we use another greater than sign. Now, take a look. We get Sony without any quotes. So we can change our where clause to something like this. I'm going to copy this entire expression and put it here. Now we get this and compare it with Sony. There you go. So this is how we can extract various pieces of a JSON object. Now we also have a few functions for updating JSON objects in our database. For example, back to our first query window. Let's say we want to change the weight of this product. We don't want to reset this entire object. We only want to update the weight property. How can we do this? That is when we use the JSON set function. Let me remove these arguments. All right. The first argument to this function is the JSON object that we're going to update. In this case, what we have in the properties column. Now we add one or more key value pairs to this object. For example, we can update the value of the weight property. So we pass a path here, $.weight, and then we add the new value for this property. Let's say 20. Now we can add a new property here as well. Let's say age. Currently, this object doesn't have a property called age, so we can set it here. Let's set it to 10. Now, let's execute this statement. Beautiful. Back to our other query window. Let's select the product ID and the properties column. All right, so take a look. Now we have the age property that is set to 10, and the weight is updated to 20. So we can use the JSON set function to update existing properties or add new ones. We also have JSON remove for removing one or more properties. Let's say we made a mistake. Age doesn't really apply to a product. So in this function, first we pass a JSON object. Then we list one or more keys that should be removed. In this case, age. So both these functions, JSON remove and JSON set, take a JSON object, modify it, and return a new JSON object. And that is the reason we can use them in our set clause like this. So we're setting these properties to a new JSON object that is returned from this function, right? Now let's execute this and make sure it's removed. So execute this one more time. We no longer have the age property. So as you can see, it's really easy to work with JSON objects in MySQL.